Okay, here we are doing Pure Mathematics Year 2 Edexcel, Chapter 2, Functions and Graphs, Question 12. Save a bit of time, I've written it out. F of x, x squared plus 6x minus 4. X is an element of real. X is greater than a. Okay, that's just a statement about a. And they are then asking state the least value of a for which f of minus 1x exists. Okay, that's question 1. So let's have a think about what we've got here to begin with. So what is x squared plus 6x minus 4? It's going to be some sort of quadratic shape, U-shape thing. Okay, and so if we plot that in and have a look at it, we have got some sort of shape like that. Call that f of x. Okay, don't know this, not sure on here either. All right, so what are we saying? We want to know for the f of minus 1. Okay, well, f of minus 1 is normally when you take your y equals x line, okay, and then from there you reflect this entire thing in the y equals x line. So it comes out like this. Now some people will draw it like this, but the reality is, because it's a square root at this point, it doesn't. So that's what your f of minus 1x looks like. Where does it start? If this is, what are we saying? State the least value of a for which f of minus 1 exists. So we are looking for this value up here. Now, whatever this minimum is on f of x, min of f of x, that will be the a value here, because that's the minimum value of where f of minus 1 exists. Okay, and that should be the same as the f of x. Okay, so where do we get that value? To find the minimum, we need to do a completing the square. So starting here with, I'm not going to use that colour pen. Right, f of x. So x squared plus 6x minus 4. Complete the square on that one. We will get x plus 3 squared. 3 times 3, doing half of the 6 there for the 3. 3 times 3 is 9, so we need to do a minus 9 minus 4. So we get x plus 3 squared minus 13. So this gives us minus 13. Okay, and what was the statement? State the least value of a for which f of minus 1x exists. Okay, so now that we've got the minimum, so the minimum is equal to minus 13, okay, and that occurs when x is equal to minus 3, or more to the point, it occurs when x is greater than minus 3, okay, because it's at that point, it's this part of the curve that we are getting reflected to give us the orange line. So it's from here onwards, it's when we go from minus 3 here onwards, that's what gives us the minus 3. They are meant to be mirror images of each other. Okay, and so for f is a one-to-one function after that point. Okay, so the least value of a is a equals -3. Right then, now they want to say that a is equal to 0. Find f of -1. So let's just quickly find f of -1 first. So if we've got the fact that f of x is equal to x plus 3 squared minus 13, we can quickly say y equals x plus 3 squared minus 13, y plus 13 square rooted minus 3 is equal to x. And so we can say, just moving all of that across and doing the square root and all of that, we can say that f of -1 of x is equal to the square root of y plus 13 minus 3. Now, when we put that onto the graph, it will look, we know it starts from here, and it goes from up here. It's a bit of a bad line. It goes something like here, and you end up with a -13 going out this way. Okay, because it doesn't exist after that 3 point, but we are now being told that x is greater than a, so x has to be greater than 0 for the f of x. So when we were on 0, remember, for f of x, which came down here to 13, and it was like that, that's your -3-ish, bad picture actually, bad there actually, minus 3. So that's your f of x, and that's your f of -1. But that was when a is -3. We've now said a is 0, so we should be ignoring all of this, okay, for when a equals 0, as given into the example up here. Given that a is equal to 0, find it. So we found it, there it is. Its domain is equal to, where did f of x cross the y-axis? F of x crosses the y-axis at -4. So f of x, so the domain is for x to be greater than -4. Okay, so they're controlling this whole thing with this a being greater than less than. All right, maybe we could look at that in something like Desmos and have a look at it at another date. Okay, so here it is on Desmos for us. You can see that we've used f of x notation, there it is, and we have used x equals f of y to draw the inverse on that. I should probably put the x, y equals x line in there as well, just so you can see the mirror. In fact, that makes it complicated. Okay, now I've got the x is greater than a, and at the moment my a is set up as -1, so we need to reduce it down so that it is at -3, and you can see there, as we get this a of -3, that is when the f of x blue line has become a one-to-one function there, and so it is a function and it's defined, and that's why we get that we found that minus 13 is at x equals minus 3, which is what defines the a and gives it to us. Now they've said, where does, when a is set to 0, there it is set to 0, you can now see that the function starts from minus 4 on it. Okay, so that we can see it. So that's what's going on with that equation. Okay.